There's no shortage of tools and choices for producing high-quality music and audio with Linux. Switching to Linux as a musician or producer is easier now than ever. If you've considered making the switch to Linux from your proprietary platform, but you're not completely sold on the idea yet, consider the fact that Linux has powerful modular audio routing capabilities and a nearly endless selection of casual and professional tools for manipulating and recording and processing sound and audio. Linux-powered studios have made the switch for the flexibility, freedom from uncertainty of proprietary formats, and the enterprise-grade stability associated with Linux. In this video series, we'll lay out, starting from scratch, with free and open source tools for beginners. We'll discuss the use case and advantages of custom patched real-time and low latency kernels. We'll show you how Windows and Mac users can continue using most of their favorite VST instrument and effects plugins that they rely on from their current production workflows. We'll also showcase the many digital audio workstations available for Linux, including the cross-platform DAWs like Reaper, Bitwig Studio, Renoise, and Mixbus made by the famous Harrison consoles. We'll then look at pre-configured Linux distros that are specifically designed for audio production, such as qJackCTL, AV Linux, and Ubuntu Studio, allowing you to minimize the learning curve and get right to work making music. Hello, and welcome to another DS Tech Media video tutorial. I'm your host, Jay, and we're returning to the Linux Do Everything Freely series, and this is going to be the definitive tutorial, I hope, on audio and music production and recording using Linux. So a while ago I created the video with this thumbnail, and I entitled it Ditch Adobe, Create HD Content on Linux with Free and Open Source. Specifically, we're going to lay out the future tutorials, and we're going to look at the main components of the Linux audio stack. So first things first, we're going to lay out some basic audio production terminology. DAW stands for Digital Audio Workstation. Digital Audio Workstation, or DAW, is a complex software suite for making or recording music with a computer. They usually have separate audio tracks and channels for playing, mixing, and recording music and audio. And the DAW also allows you to process and manipulate digital instruments, samples, and effects. You do that usually with plugins, which are standardized portable software that can be used in different DAWs as instruments, effects, or utilities. The most common plugin types are VST, which is Virtual Studio Technology, and macOS's AU Audio Unit. MIDI stands for Musical Instrument Digital Interface, and it's a standard used to connect instruments and controllers to software, synthesizers, controllers, samplers, turntables. Latency is an important concept when you're dealing with producing and recording. It means basically delay It's commonly thought that anything over 10 milliseconds is noticeable to humans. Real-time in computers has multiple meanings, but in general, real-time means that the computer has to complete a task in a predetermined and predictable amount of time. It's like a deadline. So we're going to be looking at the technologies used in Linux-specific audio, custom and patched Linux kernels that are about hardware performance and reduced latency. We're going to look at distros that are designed for doing audio and usually also video work. We're going to look at all of the DAWs and plugins, talk about hardware such as audio interfaces, microphones, and MIDI controllers, explain getting Windows VSTs running with Wine. Okay, so let's start with the Linux audio stack. Every operating system has a subsystem that handles audio input and output. Linux has 3 audio systems: ALSA, Pulseaudio, and Jack. ALSA stands for the Advanced Linux Sound Architecture. It's an all-in-one modular driver system. It powers all types of sound cards. It includes a MIDI driver. Nearly all modern Linux distros use ALSA. Next is Pulseaudio. Pulseaudio works usually with or on top of ALSA, and it's a sound server. And it allows you to take individual control of each application's volume as well as which hardware device the application plays on, such as your speakers, headphones, or even like a USB audio device. The majority of Linux distros come with ALSA and Pulseaudio included, and they do everything you'd expect from Windows or Mac OS. The third system is called Jack, and it's used for working with audio in Linux. Jack stands for Jack Audio Connection Kit, and it allows you to connect audio input and output between different applications and hardware. The focus is low latency and real time for audio production. When it comes to producing music on Linux, getting started can be intimidating because of the 3 entirely different audio systems on the back end. If you just want to quickly start learning and playing around and making beats and songs, you can skip installing Jack. However, if you have music hardware like microphones, monitors, studio interfaces, or MIDI instruments, you'll probably want to set up Jack. When I was reading up on how to make music in Linux for the first time, the forums were full of people talking about the difficulty of installing and setting up Jack on Ubuntu and having issues getting Pulseaudio and Jack to work together. Forum users would often suggest using AV Linux, qJackCTL, or Ubuntu Studio because they come pre-configured with Jack and tons of other audio tools and plugins, as well as patched low latency and real-time Linux kernels, custom tuned for higher audio workstation performance. Alternatively, Ubuntu Studio, AV Linux, and qJackCTL distros come with patched kernels, Jack pre-configured, and loads of other music software pre-installed. Me personally, I chose to start with AV Linux, and I ended up adding what I liked to my Ubuntu and Arch machines later. AV Linux uses the real-time kernel, comes with several DAWs, and loads of instruments and plugins all set up and ready to work. So now let's talk about patched and custom kernels. The generic kernel is the stock kernel that's provided by default in Ubuntu. The preempt kernel is based on the generic kernel source tree, but it's built with different configurations to reduce latency. It's also known as the soft real-time kernel. The RT real-time kernel is based on Ubuntu kernel source tree with Ingo Molnar's maintained preempt RT patch applied to it. It's also known as the hard real-time kernel. The low latency kernel is very similar to the preempt kernel, and it's based on the generic kernel source tree, but uses a more aggressive configuration to further reduce latency, and it's also known as the soft real-time kernel. And then there is the real-time kernel, which is based on the vanilla kernel source tree, meaning release candidate Linux kernel, not the Ubuntu kernel, and it is also a hard real-time kernel. At the moment, only the first 3 kernels are available through official Ubuntu archives. Another kernel that's available is the Licorice kernel, which is a truly custom low-latency kernel. Licorice is a distro kernel replacement built using the best configuration and kernel sources for desktop, multimedia, and gaming workloads. Then there are the audio distros: qJackCTL, AV Linux, Karma or CCRMA, which is a Fedora setup, and then Ubuntu Studio. qJackCTL is outdated currently. It's based on Ubuntu 14.04, which came out in April of 2014. It uses the low latency kernel. It's pre-configured and loaded with software and plugins, and it uses Cadence as a central control system for loading tons of instruments and plugins. Additionally, qJackCTL repositories can be added to other Debian or Ubuntu-based distros. However, I should note that this can cause complications and dependency problems, and it can break your operating system. So you should only use qJackCTL repositories if you know what you're doing and you have working backups of your system. Ubuntu Studio is an officially maintained flavor of Ubuntu, and it's the most widely used multimedia-oriented GNU Linux distribution in the world. At least that's what they claim. Just like qJackCTL, it uses the low latency kernel, but it's much more up to date, and it's based on Ubuntu 18.04, which is the current long-term support version. It comes pre-installed with a selection of the most common free multimedia applications available, and it's configured for the best performance for the Ubuntu Studio-defined workflows, audio, graphics, video, photography, and publishing. It doesn't include quite as many plugins or programs for music production, but you can install those afterwards. And then there's AV Linux, or Audio Video Linux, which is based on Debian, and it uses the RT hard real-time kernel by default, but the low latency kernel is also available in the repositories. It comes with a custom settings system and other performance squeezing configurations, as well as Jack and Pulseaudio pre-configured to work smoothly together. AV Linux is loaded with hundreds of third-party plugins, including some free 32-bit Windows VSTs. Another unique feature of AV Linux is Wine ASIO. In Linux, Wine is a software system that allows Windows programs to run on Linux, and Wine ASIO allows Windows native ASIO sound drivers to be used with Jack. AV Linux also includes the demo version of Harrison Mixbus proprietary and paid software, and the demo version is fully functioning except for the fact that it plays random static at different intervals if you haven't purchased a license. Karma, or CCRMA, is Stanford University's Center for Computer Research in Music and Acoustics, pronounced Karma. They host the Planet CCRMA at Home, the specific collection of free and open source software packages specifically for Fedora used by Stanford CCRMA. This collection has gotten smaller over time because most of the packages have moved to the official Fedora repository. Linux has native and hosted plugins. So the native plugins would be LADSPA or LADSPA, which are not too fancy looking usually. LV2, which are fancy looking Linux native plugins. So some are Linux VSTs and others are based on LADSPA plugins. Then we have DSSI, which is non-native Linux plugins that are set up to work natively in what's called a wrapper. So we already talked about Wine. Windows VST, VST3, and VSTi plugins are made possible with Wine. And once again, the Wine ASIO is specifically drivers for usually music production on Windows. And if we want to install certain Windows plugins, specifically like even DAWs, we can use Wine ASIO to allow Windows to think that Jack is Wine ASIO. It comes pre-installed with AV Linux, otherwise you have to build it and install it yourself. CAF Studio Gear is a collection of native plugins for Linux. It's also available, I believe, for Windows and Mac. It also has its own host that lets you run them independently outside of a DAW. Carla is a plugin host for virtually all types of plugins, and it can be ran on its own or as a plugin inside of DAW. So this is an collage design of all of the major digital audio workstations. And next I want to look at some of the key applications. We're going to look at ALSA Mixer, Pulseaudio volume control, Pulseaudio preferences, Jack, qJack control, which is the graphical Jack controller interface, and we'll also touch on the Pulseaudio Jack Connect. Okay, so I have the Synaptic Package Manager open, and all of this is on Ubuntu, but it should mostly be the same no matter which package manager you're using. First up, we're going to look at Pulseaudio volume control. The name of the package, it's PAVU control, basically a controller for all of the sound interfaces on most distributions. Ironically, most distributions do not ship with this. In my opinion, this should come included out of the box with every distribution. You usually will have to install it yourself. Not always, but usually. It has 5 tabs. Playback will show you every application that is playing audio, and you can route that to the different cards or interfaces. Recording is the same way. And then output and input is for every device, which can be monitors, hardware input devices, virtual input devices. If we go to configuration, we can see this is my Scarlett audio interface. AT2020 USB Plus is my microphone. Another important feature is in the terminal, and that is ALSA Mixer. That's available via ALSA Utils. Your distribution may or may not have that pre-installed. Let's go ahead and run that. And it is an Ncurses interface in the terminal, and if we hit F6, it'll bring up all of the different devices that are accessing ALSA. If we go and select, this is the output basically. If we hit F5, we can see the capture. They can be controlled left or right. The double zeros means output. On the motherboard, you can see we've got the internal speaker, headphones, master controller, speakers, PCM. For the most part, you won't ever have to use this, but it can be good for troubleshooting different audio levels and things of that nature. Okay, another application I want to look at is Pulseaudio preferences, and the package name for that is PA-Prefs. It's got 4 tabs. The one I mostly want to demonstrate is simultaneous output. If we click this, we'll be able to go to Pulseaudio volume control and see that we now have a new playback interface called simultaneous output, and it adds a new hardware, a virtual hardware interface that will play the output through every attached sound device. So that can be very useful. And it also has a lot of other unique features. You can enable a multicast RTP receiver or sender, which allows you to send audio from your local microphone, send audio from local speakers, create a separate audio device for multicast RTP. You can also enable network to access local sound devices on the network. You can allow other machines on the local network to discover sound devices, choose whether or not it requires authentication. You can make sound devices available as DLNA, Universal Plug and Play Media Servers, DLNA, Universal Plug and Play Streaming. You can make discoverable Pulseaudio Network sound devices available locally, make discoverable Apple AirTunes sound devices available locally. You have to install that module though. But the big program that we're going to need to talk about is Jack. Before we even start looking at Jack and all of the more complicated stuff, this is a brand new install of Ubuntu 18.04. We can open software and go to LMMS, and this is the version from the Ubuntu repositories. I do not recommend it. It is outdated and hideous looking. But if you just go down here to the website, we can go to download, and the best version to use is the app image version. And in order to run it, it's supposed to open the terminal and do chmod plus X. But we could also simply click properties, go to permissions, and execute files program, highlight that, and then we can double click to run it. And this is the latest version of LMMS. If we go to settings and audio interface, you can use Pulseaudio or ALSA. Will already be installed in your system, and you'll be able to get right to work. We can also use any connected MIDI controller like this one without any more configuration. All we have to do is click on the icon to the far left of the track, go to input, and this is my MIDI controller. And it's that simple. You could also install Ardour, which works with also. I'm not sure about Pulseaudio. So here are all of the Jack packages I have installed. Most of these will install with Jack D2 or Jack D1, and with Jack we introduced the complication of XRuns. XRun can be either a buffer underrun or overrun. In both cases, an audio app was either not fast enough to deliver data to the ALSA buffer or not fast enough to process data from the ALSA buffer. Usually XRuns are audible as crackles or pop. Various kernel patches and strategies are available to minimize XRuns under Jack. Example, kernel preemption and real-time Linux security module. Okay, so what are the differences between Jack 1 and 2? They're equivalent implementations of the same protocol. Jack 2 was originally written to add multiprocessor support and rewrite internals using C++. Why would I choose one or the other? For most folks, it doesn't matter. For others, there's typically one or two features that cause them to prefer one over the other. See below for a detailed listing of the difference. So for me, I chose Jack 2 because it supports multiple processors. It also allows apps to disconnect without disrupting audio. Interacts with Pulseaudio on Linux to share sound card. Jack 2 does that. It also has optional dbus support. Has built-in support for more than one sound card on Linux. And that is a no. But for most people that should not matter. Has built-in integration with Linux MIDI. No, and for me, once again, that does not matter. And there are ways around that, and we are going to be discussing those in this video. If you install qJackD2 or qJackD1 with sudo apt install, it will install the qJackD package automatically. If you have FireWire devices, you're going to want to use qJackD1 or 2, the same thing with FireWire. I also would highly recommend installing Pulseaudio module Jack and qJackCTL. Okay, so this is qJackCTL. This part here that says stopped refers to the Jack transport system, which I'm not using at the moment. And these red numbers here are your X runs. So the little 2 is minor X runs, and this 0 here is major X runs. They will build up over time, and that means that something missed a deadline, whether it be a software or hardware buffer. This opens your connections, and this is how I currently have everything connected. And this opens up your messages and status. This is all of my status properties. And these are all the X runs. They're not a fatal issue, but if you're having too many of them, then you know that your settings are wrong. Okay, now let's look at configuring Jack in qJackCTL. Let's open the settings display. You can leave your driver alone. It should be ALSA. It's recommended to check the real-time scheduling here. If you're not using MIDI, you should leave the MIDI driver alone. If you are using MIDI, you have raw or sequencer, and that is the ALSA MIDI. In this drop down, we have our interfaces, and I am using my microphone as my in and out interface. This is a USB mic. Basically acts as a sound card or a digital to analog converter audio interface. You should also know what your sound hardware is capable of. So this can run at 4800 or 4400. Higher is faster. Your frames per period is basically your buffer size. In programs like LMMS, you'll want this to be the same as whatever the program you're using is set to. If you're getting too many X runs, then you're gonna have to raise these settings. So I have it at 256, and the periods per buffer is like a timing interval. I've seen it recommended that if you're using anything through a USB connection, that you should use 3 periods per buffer. Down here at the bottom, you see your latency. So I'm at 16 milliseconds right now. That's not bad, but it's also not extremely fast. If this were like a live recording with audio, like a MIDI controller or an instrument, preferably want this to be around 10 milliseconds. It is said that humans can detect latency any higher than 10 milliseconds, but if you're not recording live, then that usually won't matter. Now, if I raise my frames per period, my latency is going to go up. So the idea here is to get this as low as possible. Also, the sample rate will affect that as well. So like the highest you can go is 192,000, and that would bring this down to 4 milliseconds. But this interface is not capable of that. The highest it's capable of is 48. So we're going to set that back there. And if we go over to advanced, we get a bunch of advanced settings. You can probably leave this alone. I have mine changed to jack multiprocessing. And over here, we can select different inputs and different output devices. Since I'm using both input and output through my microphone, I'm leaving them alone. The duplex means doing both through one device, or you can set it to capture only, playback only. The dithering, I honestly don't know. I leave that alone. These are advanced settings for your other use. Your priority you can leave alone. We're going to look at improving performance a little bit later. And the timeout and the millisecond shouldn't matter either. No memory lock. Do not attempt to lock memory even in real-time mode. And that applies to how the Jack Daemon is handling your system's memory. You may want to experiment with these first couple depending on your use cases. We always want to get as little X runs as possible and as low latency as possible. Also, any type of compositing window managers, Genome Shell uses a compositing window manager to give you all the nice shiny animations and effects, you know, like icing on the cake stuff. That's known to introduce extra X runs and latency in certain cases. This unlock memory will unlock the memory of common toolkit libraries like GTK, Qt, FLTK, and Wine. Can be useful at times. Hardware metering enables it if your hardware supports it. This option will set up monitoring ports so that you can monitor output separately. Soft mode ignores X runs reported by the backend driver. And then this is another monitor, but it is for monitoring your capturing. And chances are you won't need that. This also can greatly increase performance if you're having issues. It forces 16-bit audio instead of failing over 32-bit. So you've got 16, 24, and 32-bit audio depending on the program. But you can probably just leave this alone. And this one's grayed out for me. I'm not even sure what its purpose is. Under options, you can set a script to execute when you start Jack, and you can set a script after startup, a shutdown script, and a script after shutdown. So this is for making Jack or Pulseaudio or ALSA kick on or enable certain things, and we're going to look at that in detail later. Statistics is not really a big deal. It can be good for troubleshooting. Connections, activate patch bay persistence, and that's for connection persistent profile, meaning you don't want to change it, you want it to always stay that way. And we can actually set up logging for troubleshooting as well. This lets you set up how it looks. And there's some more advanced settings. You know, you can enable dbus interfaces, the Jack dbus interface. You can enable ALSA sequencer support, run Jack as a temporary server, save Jack audio server configuration to qJackDRC is the standard. This lets you enable different buttons in the interface, turn them off or turn them on. This makes sure it can only run once, and that's qJack control. You can enable a system tray icon, confirm close. It'll ask you if you want to close it or not. Start Jack audio server on application startup. That'll make Jack run automatically when you run qJack control. Okay, let's go ahead and run LMMS. Let's go to settings. And here in this slider you can see your buffer size. My buffer is set to 256, which matches my Jack setup. Let's open my connections and expand all. Left side is your readable clients and their output ports. Everything here is audio that's coming out of something. And these are writable inputs, and this is where audio is going in. So LMMS is here, and it's got a left and right out, and it is running into my system playback left and right, which is my headphones coming out of my mic. My system capture is my microphone input, and it is running into my CAF studio gear. This is my qJack host plugins that I'm currently processing audio with, so when I record my vocals it is running through here, and each one of these plugins has ins and outs in Jack. My system runs into my gate plugin. From my gate plugin we run it out to the envelope filter left and right. And then from there we run that out to the compressor, and from the compressor we run it to the system, which is what I'm hearing. And it's also running into my Pulseaudio Jack source for recording purposes. And this other Jack input client is for open broadcast server for my recording. And my Pulseaudio Jack sync is another way to route Pulseaudio into Jack for recording. Okay, so some other packages. We also already mentioned Pulseaudio module Jack. I'm gonna show you how to use that. Another program we need to look at is A2J MIDI D, and that is the ALSA to Jack MIDI connection. And we're not going to look at this just yet, but it'll be important later. With other programs like Ardour, you need to send your MIDI controller to Jack. With LMMS, there's no configuration necessary. It already works with the ALSA MIDI. Another program you're going to want to have installed is called PA Control, PACTL. We want to load our modules for routing audio through Pulseaudio to Jack. We can do PA Control, load module, Jack, and then we would do sync, and once that's running we can do source. And that is how you get these sync and sources to appear to your Jack daemon. Right now my non-music and recording audio, like my audio from my Brave browser or Firefox, Chrome, is still running straight through Pulseaudio like it normally would. So it's coming out of my regular speakers. And if we want to run Pulseaudio audio into Jack for whatever reason, all we have to do is go over to Pulseaudio volume control, and we can go to Brave, That's my NVIDIA card, and we'll route it into Jack Sync, and you'll be able to hear that it's being recorded through the Jack interface. Temperatures and safe ranges. It's also improving my performance overall because the CPU will throttle a whole lot less. I'd recommend this. The Pulseaudio sync acts as a way to route playing audio, so output audio from Pulseaudio, and the Pulseaudio jack source is for routing. If I had another microphone recording into Pulseaudio, we could route that into jack as well. Now once you have all of these little connections set up, if you have one that you wish to save, we can go to right click anywhere in the qJack control window. We can go to session and we can show our sessions. We can load a particular session. These are our recents. We can save and quit, and we can save template, and that way you don't have to reconfigure everything each time. Okay, so that's going to be the end of part 1 of the guide to producing and recording audio with Linux. This was kind of the more boring stuff. We're just going over all the technical aspects of it. And if you have any questions, please feel free to comment below. I'm going to be recording several other videos follow up to this. And in part 2, we're going to look at the specific studio distros. So KX Studio, Ubuntu Studio, and we're really going to focus on AV Linux since that's where I started with music production. And from there we're going to be looking at more of the fun stuff like the actual software. So please check back for parts 2 and 3 and maybe even 4. I'm not even sure yet. It takes a little while to record these. That's not the simplest stuff to do. But anyways, I thank you for watching. Like I said, if you have any comments, please leave them below. I'm Jay, and thank you for watching DS Tech Media, and we'll see you in the next one.